dear students, welcome to ME Education. Today we are going to discuss a very interesting topic, electric current and circuit. Let's start the session. Let's have a look on the electric conductors. Okay, you have seen lightning of the bulb. Okay, to lighten the bulb, you have seen some wiring. So what does it mean? How are you able to lighten the bulb? Once you imagine it, those materials are helping to lighten the bulb. Some materials can't allow the charges to flow. Some materials can allow the charges to flow. Any substance which allow the charges to flow, those materials or substances are called as electric conductors. That is the definition of electric conductors. When charges are flowing, then current will flow. Understood na? So current, you can lighten the bulb. For lightening the bulb, charges must flow. Charges must be in motion. Understood? So some materials are allowing, some materials are not allowing. Whatever the materials are allowing electric charges to flow, those materials are called electric conductors. What are the examples of electric conductors? Copper, silver, gold, aluminum, iron, mercury. These are different examples for electric conductors. Aqua solution of salt also acting as a electric conductor. Just observe here, I want to lighten the bulb. For that, I am using a battery. Battery is having positive terminal and negative terminal. You can see the bulb you are connecting by using copper wires. Copper wires can allow the electric charges to flow. Okay, just see the connection. One, okay, positive terminal of the battery connected to the one end of the bulb. Negative terminal of the battery connected to another end of the bulb. In this particular connection, you are observing lightning of the bulb. Okay, how the bulb is glowing? That is because of flow of charges. These materials allow the charges to flow. That is why you are calling it as electrical conductors. Now, see this. Just observe. What are the different examples for electric conductors? First, just now you have seen copper. After that, silver, gold, aluminum, iron, mercury. Okay, we are having some materials to use as a electrical conductors. These are the some of the list of electrical conductors we are using in day-to-day life. Okay, wires, copper wires, silver and gold, aluminum wires and copper wires, iron and mercury. These all are allowing the electric charges to flow. Understood? So now we can spend some time on electric conductors. We already seen the definition. Just observe here, aluminum wire. See the connection. Initially it is not connected. So now positive terminal of the battery connected to the one end of the bulb. Negative terminal of the battery connected to the another end of the bulb. Once you observe, bulb is glowing. What is the reason for glowing of the bulb? How to lighten the bulb? We can spend some time on that. Just observe. See this. See here. Initially it is not connected. After connection, you are observing lightning of the bulb or glow in the bulb. What is happening inside the wire? Okay. So how you are able to lighten the bulb? That is very, very important. So we can try to understand the flow of electrons and direction of electric current, and we can introduce some basic definitions. Just observe what is happening inside. Here, what actually happening here is electrons will flow from negative terminal of the battery to positive terminal in the circuit. What is the direction of flow of electrons? Electrons always flow from negative terminal of the battery. Okay, so if you assume it as a circuit, of course it is a circuit, closed loop. In the closed circuit, so you will observe the lightning of the bulb. Okay, so here electrons will flow from negative terminal to positive terminal. Understood na? So electrons will flow from negative to positive, negative to positive. So what is that conventional direction of electric current? Conventional direction of electric current always opposite to the direction of flow of electrons. Okay, we can discuss electric current and conventional direction in upcoming slides. Now, as of now, you should know electrons always flow from negative terminal of the battery. Now, just observe. See this. Just to see here. Now we can spend, you can play the game here. So I cut the wire. It became open loop. Air present in between. Air is the bad conductor of electricity. That is why you are not observing any glow in the bulb. It's a open circuit. Now I want to close the circuit by using any electrical conducting material. So now I am taking iron nail is connected. I am closing the loop, you are observing lighting the bulb. Okay, so if you close the circuit by using any electrical conductors, then you can observe the glow in the bulb. That is the closing of electric circuit. Understood now? So initially there is no connection, there is a stoppage of flow of electrons here. Okay, so in this, air is not allowing to flow the charges. That is why air is bad conductor of electricity. You connected the nail here, then this iron nail allowing the charges to flow. That is why you are observing glow in the bulb. Understood now? So here we are seeing some arrows, right? Those arrows are giving conventional direction for electric current. So here conventional direction for electric current always opposite to the direction of flow of electrons. Understood now? Here after closing the circuit by any electrically conducting material, it allows the flow of charges, then current is flowing. Finally, you are observing glowing of the bulb. This is the procedure to lighten the bulb. This is all about electrical conductors. Now, let's have a look on the electrical insulators. Some materials are not allowing the charges to flow, like air. Okay, now some materials not allowing the electric charges to flow. Those substances or materials are called as electrical insulators. Just observe here: rubber, glass, plastic, wood, some of the examples of electrical insulators. Here I connected the thread. I replaced copper wire and introduced a thread. Understood now? Now, are you observing any glow in the bulb? Okay, there is no glow in the bulb because this particular thread is made up of rubber or normal thread, woolen. Those things are not allowing the electric charges to flow. Here there is no flow of electrons, then there is no electric current. That is why you are not observing any glow in the bulb. Understood now? Here rubber, glass, plastic, these materials are acting as a electric insulators. Okay, these are not allowing the charges to flow. These are the examples for electrical insulators. Hope you understood the difference between electrical conductors and electrical insulators. Simple difference here is electrical conductors can allow the electric charges to flow. Electrical insulators can't allow the electric charges to flow. Okay, that is the basic difference between electrical conductors and electrical insulators.